Good afternoon. Welcome to part 4 of AsyncAPI onboarding workshop. And as usual, I will not start immediately. I need to double check if the live stream started actually, and send some links to the live stream to the community so they can join. So if you're already watching live, thanks for joining. Go to our YouTube channel, please. If you're watching on some different media like Twitch, and leave a comment in a live chat, say hi, or you can join this Zoom call if you want, because we're the stream goes through the Zoom. So in the meantime, like, just give me a few moments to grab the link to the live stream. Okay, I see it started. So yeah, just keep in mind that during the live stream, I'm only able to follow with just one chat, including Zoom. So I only follow YouTube chat. Okay. I'm gonna drop it in our Slack. Today we will, you will as well, I hope you will as well, create AsyncAPI documents, like real AsyncAPI document from scratch. The idea is that I will explain how the theory is presented in this AsyncAPI files. Hey, Pedro, thanks for joining, man.
Hi, Lucas. How you doing?
Now much better. Morning was tough.
You are better than last week.
Yeah, and it's like too hot.
Yeah. Same here.
Yeah. I'm for now then still sharing some links on Slack, giving people time to join, because the plan is that today I'm gonna in live create an AsyncAPI file, and best if everyone does it on their own in their editors. So let's give them like 2 minutes more. And if already someone is watching us on live stream on YouTube, please drop a message like a hello, so we know there are some humans there. And also for others, like as like Pedro joined, others can also join. So if you have some questions during the workshop, you can ask them live. And even though it might look like it's this live stream, this Zoom room is not only for bald guys. If you have a lot of hair on your heads, you can also join. Like, so it's not only for us. Okay, I think I shared it everywhere I could. There are comments already in YouTube, so we have people watching. Awesome. So I think we can. I'll just prepare the screen, and we can go into screen share. Okay. Can you see my screen, please? Can you confirm, folks? Awesome, perfect. So as a reminder, like this is part 4 of the onboarding, even though I planned 3 parts, but yeah, it just requires more time if we want to slowly like introduce every concept in AsyncAPI and event-driven architectures. But the plan is that today is really the last part. So even if 1 hour will be not enough, I will push and I will just simply continue. So of course you don't have to watch longer than an hour because it's recorded, but I just don't want to, like, this last part, I want to keep it together, even if it's going to take 1 hour, 30 minutes. But the good news is that another AsyncAPI live stream starts in 2 hours. So I cannot talk longer than 2 hours. So at least there are some boundaries. So the link I will share in, I just sent in YouTube live chat, link to the workshop. And quick recap from last live stream. So during the last live stream, I introduced AsyncAPI. Yes, at live stream number 3, I started talking about AsyncAPI, not sooner. And I basically explained, from my perspective, all the most important features and bits and pieces in AsyncAPI that you should be aware of. It took the whole hour. And today, when I will be like creating this AsyncAPI file live, you will basically you will be I will be explaining, like, every single line that I add. I will be referring to my previous live stream to kind of, you know, like, first I talked about theory, now practice, and let's connect the dots. So it's not just theory, but actually in practice you see the feature in action, what it gives. So so from the script perspective, we are in a script called AsyncAPI step by step. So from the script, it is number 5 on the list. So we start with number 5. So please, the best, I think, experience will be if you will create AsyncAPI file at the same time as I'm doing it. So choose your editor. There is VS Code extension. I think that still it is not labeled as AsyncAPI owned, but it's in the, I think Ivan is still the owner, but he donated the plugin a long time ago to the initiative, and we're actually in the process of taking over the brand. So it's clear it belongs to AsyncAPI, and it's pretty refreshed. So it's using already the React component that we use for rendering documentation. So you can try with VS Code extension. If you do not like UIs, I definitely recommend you AsyncAPI Studio, because I'm going to be using AsyncAPI Studio during this live stream. But you can also use simple editor, and then, for example, AsyncAPI CLI to just validate the document. Or if you like Java and you are into IntelliJ IDE, then there is also a community built plugin for IntelliJ. As far as I know, it does not support latest AsyncAPI version, but it shouldn't be a big problem. Just use 2.0.0. But yeah, again, AsyncAPI Studio to the moon. I definitely recommend you to use that. Now, just give me a moment. I'm gonna move the live chat to the side, so I see it. And we're ready to go. The AsyncAPI file that we will be creating in the UI, it is an AsyncAPI file that I created last year It's for some to have some dummy example. It's called ShrekApp, and it's basically somehow relating to the first diagram you could see on one of my first live streams when I was explaining asynchronous, and there was Shrek and the donkey. So that's why it's a ShrekApp. So let's start. Let's actually stop talking because I'm talking a lot. So that's the studio. So studio.asyncapi.com. I think it's large enough. If not, then just dropping me a message, folks. So it's like a classical editor. So you have that's where we put our AsyncAPI document, and on the right we will see how documentation is getting generated after we provide data on the left. So we always and yeah, the first we need to decide, as I said during the last live stream, AsyncAPI is machine readable, YAML or JSON. So you can write these documents in YAML format where you need to be just careful about indentation, or you can write it in JSON where you just have to be super careful about curly braces and quotation marks. So I can't imagine someone choosing freely using JSON. So we will use YAML. And if we're using YAML, then yeah, it's cleaner. You're going to see that the document is much cleaner. And first information that we need to provide when writing AsyncAPI file is the AsyncAPI file version. So sorry. Okay, so what is, like, even in such information like just the version, what's so important here? Important is to remember, like in this, especially in the script, you have a link. The AsyncAPI, maybe it's not an app, it's a spec, but it also evolves and it's versioned under semantic versioning. And we regularly release new, excuse me, new versions of it. Every 3-4 months. Next release is scheduled for September. So you need to be also always careful about like what version you want to use. Of course, the best is if you always use the latest. So yeah, that was the easiest one. Like, next one is the info object in the AsyncAPI document. So you can like info object holds information about the application. So again, going back to the script from last week, I told you that like the basic concept for AsyncAPI file to dot version, to X version, is that we describe the interface of the application that user can interact with. So that's why we need to provide the information about the app. They need to know what's the name of the app. So people need to know what's the title of the app. And people also need to know version of the app, which, let's say it's going to be version 1. And that's the minimum you have to provide, which means title and the version, they're critical. This is like critical information. Therefore, in the spec, we specify that information like title and version is required. If you do not provide it, the file will not go through the validation. It will be an invalid document. So yeah, keep that in mind. And before we do the more information in the document, let's just do something like this. So we basically want to get rid of all these red lines and errors, because as you can see, like the document, while writing the document, it's real-time validated. So that's why we were basically getting errors that we are missing some additional fields, because it's not just it's not only AsyncAPI info with title and version required. Channels also has to be there, but it can be empty. And that's the most minimum AsyncAPI document, not very much useful. But yeah, we're fixing it simply this way. So simply we can already see rendered documentation on the right. So for now, we just have the title and the version. We definitely need to provide more information for the app. So that's what description is for. And I'll just copy paste because I have long description in my example that is in the script. And it's simply to show you to present one of the features that we support in descriptions in AsyncAPI, which is like we can also in the YAML file provide multi-line scripts, and we support that the descriptions are written with Markdown. So that's pretty critical, but I think that dancing Shrek all the time on the right will be super annoying. So let's remove that green monster for a sec. Okay, cool. So we have the basic information for the user, like what's the title of the app, what's the version that they're interacting with, and the description. Now, the next information you want to know is how you can actually connect to the API. So in this case, this example is based on the application that is a WebSocket server. So we basically need to specify like what's the URL of the server and what protocol is used in that application. So it's an object called servers, and you can have multiple servers because you can have, for example, multiple instances of the application in different environments. Like you can have a test environment where you're just testing application and it's not available to public, or you can have a production server. So you can have multiple servers. You just need to provide the name. So swamp and yeah, URL. And in our case, like it's just gonna be localhost because like it's not a real application. It's not hosted anywhere. So we don't have any real URL. We are able only to start this application locally on a localhost, which is also valid URL. And the protocol is WS, which is scheme name for WebSocket. It could be also WSS, like with HTTP, and HTTPS, which is secure WebSocket. And that's again like bare minimum I need to have about servers. So just one server with an URL, with the URL and the protocol. And you can see it's already rendering in the documentation. So that's already giving me something. But so far, what I know from this document is the name of the app, the version of the app, and how to connect to it. There's no security, which is cool. I mean, it makes it easier to connect. But actually, what I can connect to, like what are the channels? So what are the connection points available there in the server that I can get messages from, and like basically what messages I can actually get from the system. So we're going to do something like this, and we're going to define two channels, but we're just going to provide names. So it's chat and travel status. And that's it. We will not provide more because, yeah, again, I'm biased, and that's how basically I would design my application. That's how I would write async API file for my application that I don't know yet how the API will be structured, because like the first thing I'm actually thinking about is the messages, like what messages will be available in the system. I only have this like foundation information that I know that the server will be available, like we'll have chat functionality, but it also will provide the status of the travel. And we're talking about the travel. Not sure if you know why I'm mixing Shrek and travel. If you know the scene when Donkey is asking Shrek, "Are we there yet? Are we there yet? Are we there yet?" So that's the reason. It's not related to flight status at all. Example from the first live stream. So yeah, I know that the server will have two functionalities, but the main information I want to know like is how the message for the chat will look like, how the message will look like for travel status. So that's why I always recommend, and it's also a good practice because automatically you think about better structure of async API document and sharing information. So I always recommend to start with components. Because components is it's an object in async API document that allows you to like put a lot of messages, put a lot of schemas, and then sometimes you might have a situation that schema is the same for two different messages. So we can reference instead of duplicating information. Last week we were talking about one of the very important features, which and optimization of the structure of the information in the document, which is JSON reference. So yeah, we will definitely use it here. So the information we put in the components, and then we can reference them in other places. And before I continue, there's a question in YouTube. I'm assuming if someone wants to document an async API, they should have a total understanding of what and how the API will display messages in the system, right? Yes and no. Like basically yes. To provide async API document with good data, you first need to have this data. But async API and Open API and other specs, they enable you to actually design the application. So it depends. So if you're writing async API document for existing API, then yes, you have to know first how the messages look like so you can describe them. But sometimes, like for example, with this async API document, Shrek app, when I was creating it last year, I didn't have my app. I didn't have my API. So I was designing it basically. Like I was like experimenting how the message will look like. And then I could see it in documentation. So I did not have a info how the message looks like prior creating the async API file. Async API file actually enabled me to work on this design and brainstorming how the message could look like, what properties I could have in travel status, for example. So yeah, depends on the context. Again, like with everything, it depends. Okay, so components and messages, right? And there will be, excuse me, two messages. So the first one is for the chat. Let's call it chat message. And yes, the best practice is to provide the summary, like the explanation for the message. And I'm just cheating and copy pasting the description. So the message, that is the message that you will send or receive from the chat. And this is the easiest looking message that you can imagine. It's not very complex structure of the message because the payload of the message is of type string, and that's it. And you can see already, like even though I don't have yet operations defined, I don't know yet if there's any publishing or subscribing available, but I already can see the messages in the that are in the system. So I can already like tabach to again answer your question additionally, like again, during designing, I don't know how the message looks like, and it helps me like to visualize and see like, because it's much different when you read a YAML and when you read actually beautiful docs. I like my personal feeling, not based on any science, is I think that just the brain works differently and understands things differently. And it's just much clearer to read it this way than to read it that way. And looking at the message summary, that's obvious what the summary is for, but the payload. So the payload comes from, again, last week we talked about, you see even examples here. So we talked about schema of the message. I try to explain like what it's for, like it's that you can easily validate then the messages. So you basically, the schema tells you like how the message, actually, sorry, that's the actual message. And that's the example schema. So in the schema, you can say, okay, there should be display name and it should be string. There should be email, and the type is object. So that's what payload here is like. So in the payload, we say that the type of the message is string. It's not even an object. It's just a simple string message. So that's payload, what payload is referring to. And by default, I'm not specifying any specific schema format like Avro or anything like this. So by default, the tooling assumes that the schema that I'm using here is AsyncAPI schema, which, not sure if you remember from the last live stream, it's a superset of JSON schema. So it's basically JSON schema with some additional fields or some modifications in the spec. And there's a question, could someone please share this message schema markdown file with me here? Yeah, I can share you actually the whole, actually whatever I'm doing is the step-by-step instruction that is available here. Just confirm if you got the link. Okay, so we have pretty simple message, but now it's, again, it's a simple message. The next message, the message related to travel status, it's gonna be an object. It's not gonna be a simple string. So so yeah, let's just write that it's gonna be called travel info, and summary will be the message that contains information about status of the travel. And we will not yet provide payload because we don't know yet how it looks like. And we definitely do not want to do it in case of this message directly under the message. And I think we can first define the example. So in AsyncAPI, you can also provide messages example. And that's what we're going to do. You can provide multiple examples. So the message payload, and why we need to explicitly say payload, because you can also have message headers. In some protocols, they are supported, but not in case of WebSocket. So that's why we don't have an example of a header here. But normally I would just have to specify that it's an example for header. And the payload, so there will be a field in the object that is called destination, and the example will be far, far away. The distance, and let me just copy the description, the example. So the distance will say, for example, like beyond the 7 mountains and 7 forests. And arrival, so information when you arrive. So I know that my my message, the basic example is that there will be for sure three properties, and they all will be string, nothing more complicated. And now I can actually go to description of the schema, which is again like much more complicated than simple string. So we introduce another components object, which is not only messages, but can be also schemas. And in schemas, we will define a schema for travel data. Let's call it travel data. It's just an ID. And the type is not string, it's object. So if it's object, and as you can see, sometimes it's just enough to say that it's going to be an object, and that's it. You don't specify any properties. But in our case, in this example, we want to specify the properties. So one of the properties is destination. Excuse me. And yeah, I will copy paste description because I'm not a fast typer. And we need to say, okay, if it's if destination property, that's the description, and we need to say its type, which is string. And I will just copy paste the rest. So we do the same with the rest of the properties. As you can see, with YAML, pain is the indentation. If you don't keep it correct, it is throwing a lot of errors. Sorry. And yeah, in YAML, copy pasting can also cause a lot of headaches. Yeah, so you can see already the message 1, 2, and the schemas is available. So there's a travel data, and you can see that as a user of documentation, I can clearly see like how my object should be structured. And like in this view, you cannot see it, but like in the generated documentation, you will also see the example rendered in the UI as well. So I have the schema and I have the message, but how to connect them, like how actually say that this schema is for that message. And this is what, again, this feature that we were talking about. Oh, whoa. $ref. And in $ref, excuse me, we have to provide the basically a reference, a link, kind of link to the schema. So we can see that we provide a string information that starts with hashtag that indicates that the reference inside the document, because we can also have references to outside documents. And we say, okay, in the components, so here, in schemas, so here, just take travel data, and basically during the dereferencing, when we parse the document, even though here you don't see information about payload, but just the reference, but in the final document that AsyncAPI documentation generator uses, payload is available, so it can be rendered in the UI. So it's called dereferencing, basically, which means that in the final document, instead of $ref, you would simply see this. Like, so the dereferencing is basically moving things between, of course, pasting kills document. So so that's what we have already. So we We have schema for the message. We have both messages described. We have example of the more complex message. So we managed to design like what messages will be available in the system. Now we need to say like which ones you can actually send to the system, to the API, or which ones you can just read from the API. And that's what operations are for. With 2.x versions, operations are inside channels, and you have to like when you start describing the channel, you actually start with the name of the operation. So there are two operations, subscribe and publish. So again, last week I tried to talk about this semantic issue we have with publish subscribe. So again, like just remember that when you think about saying that the API can publish or subscribe, you always have to describe it for the user that will use the API. So when I will write here, subscribe, and then put summary, then it means let's say I don't provide more information, then it means for the user that the user can actually subscribe to this particular channel, not that the Shrek app is kind of subscribing to the channel. In case of WebSocket, it's easier to understand because WebSocket is kind of broker. In case with broker-centric applications, that's much more complex. That's why just remember about this semantics issue. I will specify operation ID, which is for just like information about message. Sorry, like for information about the API. It's only needed basically when you think about coding and code generation, because the operation ID is something that while you generate code, you should use for the names of the functions. Now, as you can see, we don't have yet the chat connected with the chat message. So things that are under components can also belong to channels. So I basically say message, and I don't have to again provide all the information about the message, but I use $ref again. And in $ref again, I point to components, messages, chat message, and it looks like this. And you can see in the generated documentation that like finally I got some operation. User can see that there's a chat channel, what's the operation ID, and yeah, can see what messages are available under this given channel. Now, the case with chat is that you usually send a message and receive the message, right? It's a chat. So you can also you can not only just read messages, but you can also subscribe to messages, but you can, as a user of the API, also send messages, so publish messages. And I'll just copy paste because it's basically the same, just the operation ID name is different, and of course the summary. But yeah, with publish, client can receive chat messages, client can send chat messages. And again, it's the same message. So you can already see this optimization of the document to make it smaller. You simply define the message once, because for both operations, it's the same. So you can reference it twice. It's the same like with coding, like you don't write the same function twice. You just put it in utils and then reuse the function. Here, we just reuse the information. Now, if it comes to travel status, I cannot send, I don't want anyone to send any messages to the API. I only want people to subscribe. So I want Donkey only to be able to get messages. And so he cannot poke me and ask me for messages. He can just wait, or it can just wait for the messages. Again, summary. Operation ID. And of course, message. And again, we use reference. We don't duplicate information. So we need to point that we need to dereference information from components, messages, and travel info. So we have pretty much a lot. And everything like from the basic information perspective. So as a user of the API, I know what it's for. I know what how to connect to it. I know what operations I can perform with the API, how to connect, and what messages I can receive or send to the API, and how they look like, what's the schema, which is perfect. Now we will do something more, something that, again, like last week, we talked about the killer feature of AsyncAPI, which is that AsyncAPI is protocol agnostic. So you can see that even though the application that I was writing here is for WebSocket, but there's nothing WebSocket specific in this document, like nothing, but like basically all is super generic that you need to know about any API, no matter what the protocol it's using. But I need to provide some additional information just for WebSocket. And that's where we use bindings. So this kind of micro specifications for a given protocol that we use at AsyncAPI. So we basically need to specify on the channel level, that the travel status, when I'm connecting to travel status, I want to specify that this particular channel, I can put some query parameters when connecting to the server. And with the query parameter, I can specify that I want only status from a given destination. So let's say not all the destinations, but just one. And I could, like my API could support something like this. So let's go below subscribe, bindings. And first thing you do with bindings, you say which binding you're using, which is WebSocket in this case. And again, like the first information is binding version, because yeah, it's like with the spec. AsyncAPI spec has versions, and the specifications have also their individual versions. They're not bound to AsyncAPI version. So yeah, let's use the 01, and let's specify the query. Just to quickly give you how do I know that it is binding version and query. So in bindings, we have the specs for different protocols. And we know that there's a channel binding available. I know what kind of details I can provide, and I know that I can provide a query property in the schema, and I can use here a schema object to describe what what values I can put in the query when connecting to the server. But I need to remember that it has to be an object and it has to have properties key, which makes sense because in the properties I'm going to provide names of the values that I can provide in query parameters. So there will be one query parameter available. So again, like let's just copy paste a bit because we know it must be an object. It definitely doesn't have to, but it's recommended that it has a description. And it has to have properties. And we know that there will be one query parameter, which is destination. What did I just do? Did I just broke AsyncAPI Studio? Let's remove, let's hack it a bit. Storage. Because now we have Studio. I'm gonna lose my document, but it's not a problem. I'll just copy paste. Okay. Yeah, some different stuff got loaded. Luckily, I have the document in the repo, so I can just copy paste. And Maciej, if you're watching, that was super weird what just happened. Okay. Channel. Okay. Okay, so we're back. There's probably something with the parser or in the studio that it didn't like that I broke the document in the way. I don't want to try to break it again, but I think it's because I didn't have this part and it failed. So yeah, that's what, sorry. So that's what was missing. Can you hear me, though, Pedro? Oh, interesting.
Now you're back. Yeah.
Okay, thanks. But you could hear, right? You didn't.
Oh, yeah. We can hear everything. Yeah.
Okay, perfect. Sorry for that. So Studio even broke my camera. So that was what I was missing when the document broke the Studio. So I specified that, like, according to the schema of WebSocket binding, I can specify that basically whenever somebody connects to the travel status, they can also do something like this. Destination BCN, for example. But because in the spec, it is not allowed to write such a name of the channel, this is why you have, and it's needed only for WebSocket. That's why you have WebSocket binding and the specific feature here that allows you to specify the query. And then, again, it's available in the documentation. So I know that travel status have some specific WebSocket information. and I know that I have a query available, and it's a destination. The value is destination. It's about airport code. So I specify that I want to have updates only from a given airport. That's it if it comes to bindings. So something to I'd like to emphasize again, remember, AsyncAPI spec itself is protocol agnostic, and it has its own version and is released separately from the bindings. Every single binding has its own spec, it has AsyncAPI spec is a markdown file. The bindings are also have also markdown files that specify what you can provide for a specific protocol. Sometimes there are different code owners and maintainers for bindings that the maintainers for the main spec. Because in event-driven architectures, there's a extremely high amount of protocols, and it's not possible that one person knows all. So that's why we always encourage community to just jump in and become maintainers for a given protocol if they're experts in it. Okay, so what next? Extensions. So okay, again, last week I talked about another AsyncAPI feature, which is the extensibility. So basically, which means that I cannot just provide whatever I want in AsyncAPI document. I cannot just say, I don't know, whatever. I can't just add new property. It's not allowed unless I do it this way. But then it's just here in documentation, it's ignored. We don't know this extension that somebody would use. In some fields, we do render extensions that we use that we see in the document. But yeah, that's I don't think it's a topic for this workshop, for this onboarding. Just remember that these extensions, we want to there's a extension catalog repository in AsyncAPI, and we want to kind of try to help community share extensions and also push for the solution that to add a new feature in the spec, you actually first add it as an extension. We see how it's used by the community, and then we can pull it into the main spec. So, but extensions can also be used I know, for example, from the presentation from Walmart from last year, that they provide some additional information that are Walmart specific. So extensions that they will not share with others, that they will not even push for the spec, because it's somehow really super specific for their architecture, for their solution. And they just do X, they do the pattern like X. And that the same would be with any other company. It's just the practice that they, I think, that started using when OpenAPI was introduced. So yeah, so just remember, simply the example I have here is that I'd like to know as a reader of documentation that when I subscribe to chat message, that I will receive also what I will receive in the response, that there will be response, not direct, still async, but that there will be response. So I can, for example, I can do it using the extension. So I can go to let's go to the message, chat message. Oh yeah, I already have it here because I copied the correct document. So I just add additional field, X response, put the description and say response will be available here in the payload of the message. So, and as I said, sometimes we do support them in the docs rendering, and render them as as good as we can, even though we don't know what's the schema of this given object. There are two more features I did not cover. It's just not possible in one such a dummy example to provide all the examples. And also this feature that I did not explain is, I don't think it's so widely used, it's traits. So in the script that I linked in the chat, there is an example, a link to an example in Kafka based example where traits are used. So I'll just quickly show it to you. What did that was definitely not what I wanted to copy. Okay, so you can see this example of AsyncAPI document where you can see something like operation traits and it says like Kafka, so the name of the trait, and then that you want to reuse, but it's different kind of reuse. So let me just show you first how it's referred to. Okay, so you can see, for example, there's a channel, some channel on the broker. We know that with this application, we can subscribe to this channel to receive information, and it's Kafka, and the client ID everywhere will be the same. So you want to reuse a binding information here under every operation. But with reference, it would not look that nice. So you basically say, okay, traits for this operation, there are some traits, point to the trait. And it basically means what will happen in the parser is that we know that in this given operation, we need to take from this location, this trait, and this entire field will be like injected in the operation. So it will not be like with reference. It would usually be like, you know, with simple dereferencing, it would be embedded under traits, but it's traits. It's not simple references. So the whole binding information will actually be injected between, like on the same level that other properties like name, title, summary. So I think I can quickly show it to you in the studio. Because with words, it's, yeah, master of copy pasting. What did I do? No, seriously. Okay, so again, like let's say this first. So you can see every operation has this trait reference, right? So let's see, lightning measured, that's clear. And we can see that there is operation-specific information about Kafka and the client ID. And here you can see there's nothing about Kafka and client ID. We just have a reference to operation traits Kafka. So you can see that whatever we see rendered here under operation is exactly the same thing that is provided here. So it's just, so traits like are like again, it's a feature for better organization of your AsyncAPI document, for reusability, and something a bit different than ref. So yeah, you need to know what you're using for what. But again, it's just about not writing the same stuff twice, but reuse. And one thing I didn't show you, I think I mentioned, but didn't show you was, but it's not possible in the studio. Like Studio is a web app. We don't yet support references to external files in the file system. But yeah, you have an example of AsyncAPI file here where the reference, you can see it doesn't start with pound key or hashtag, but it starts with just actually pointing out that it's a relative path to some file and a specific property inside the file. So that's how references are powerful, that you don't only reference things inside the document, you can also reference outside the document, like documents that are not even AsyncAPI documents, but they are JSONs at the end. Of course, this is YAML. So yeah, that would be it if it comes to creation step by step, and we managed to do it in 1 hour, but that's not yet everything. So let's go back again to Shrek. So I hope you managed to get the get there where I am. You can see documentation rendered, but now the most important question, like, why do we even do that? And even in the script, I think I have a nice catchy phrase, which is, give me a second. We're going to another script. What can I do with it, basically? Okay, so you basically went through the hell of writing the YAML file. You could already see like it's nicer than JSON, but it has also this stuff that pains a lot. I have constantly issues with copy pasting parts of YAML, so you need to be very careful about identation. So there is a huge community of people that basically hate YAML, but there's nothing better. And so you went through the horror of writing the YAML file. You went through the horror of actually learning the specification, because to write the YAML file, you need to know what is there. Of course, we have some examples that help you to kick off and like just copy paste and then modify, but you still need to learn the spec. And what can you do with it? Like you could see already, like I'm describing my app, and this allows me to generate docs. But like, is it really worth it? Like, I mean, I think it's, that was a stupid question. Like, I think it's actually worth it, like even for documentation, but documentation you can also write by hand. Of course, with using AsyncAPI, you don't have to worry about the structure of the document, style of the document, because the documentation generator will do it for you. But like, if you already went through hell of writing not something so beautiful, but writing something so YAML-ful, that the machine can understand and give you nice documentation, then why not use it for different use cases? So definitely don't stop with docs. Docs, I think, should be always the first goal, the first step, because that's the easiest to achieve. Now you write the file, you get the docs, but then push the boundaries and try to use this AsyncAPI documents for more, because if machine can understand it, that much more can be done. And like one of the use cases is real-time message validation. What it means, let me actually just link you to, maybe I'm not going to link you to this repos, just have a look at them later. It might be just too technical, but basically real-time message validation is where it's not about validating AsyncAPI document. it's that just look on information that you have available in the AsyncAPI document. You have the information, the schema of the message. You know exactly how it should look like. So it's not only for documentation reasons that you create this schema. It can also be used in the runtime of the application when it's running, when you validate incoming message. Like so, so let's see, I'm writing an application that is subscribing to the travel information data. And I want that my application that reads the messages checks if the incoming message looks as it should look like. If it has destination, if it has distance, and if it has an arrival, and if the type of the information is string. Like what I would have to do if I don't have a schema, I would have to write everything with code, like manually provide validation code that checks incoming payload, destination, is it string? Okay, then if distance is string or not, if arrival is string or not, then approve it or drop an error that instead of type string, I got integer. I would have to code it all. But schema is for actually for validation. So there are libraries that you can put your schema through the library, get validation code out of the box, and then validate the message, the information, the object against the schema. And the validation library will handle the validation because everything it needs to have is in the schema. All the information is in the schema. You only have to integrate the library. You don't have to write the validation code, which saves tons of time. And not sure if I'm going to be able to show you the example. Actually, I'm not going to be able to show you the example with this service. Okay, let's do it quick. I think it should be quick. We're gonna already show you the example of code generation. So we have AsyncAPI docs, and there's a beautiful tutorial, and we will just go through it very quickly. Not the interactive one, but the example one. We are actually gonna live check if it works. So we have some example AsyncAPI document, blah, blah, blah. I already have generator installed. Okay, so let's create new directory and go into it. So I have a terminal opened. Okay, let's just copy the document and create it directly. Yes, AsyncAPI YAML is created. And let's run some the generator that will, using the AsyncAPI file, will generate entire Node.js application basing on the AsyncAPI YAML file, which out of the box by default will have validation of the messages included. So you, like as a developer, you just write an AsyncAPI file, and then you really only focus on so-called business logic. So the code that is super specific for your use case, for your application. But all the other code can be generated. So we're running the generation. Let's quickly. Don't be so slow. Okay, generated. Okay, we see the application got generated. Now npm install. Npm install. Let's clear the screen. And we have already another window here. Okay, npm start. Oh, wrong, npm start. So you can, like, I mean, can be there a better example, like what you can do with AsyncAPI document. You see that I was able, when I just have an AsyncAPI document ready, there are some projects available in the community. I could like really super quickly generate a real application. And I know that I can subscribe to it, and it's an MQTT application. Now, let's interact with the app. Oh, we should actually not start the Mosquito broker, so we have to fix that. Yeah, we need only the MQTT library. I have it installed already, and just have a look at the message. So I'm sending a message to a broker, MQTT broker, to light measured channel. And I'm sending a message that I know from the docs that it has to have an ID, integer, lumens, integer, and sent at a field with the date and in a specific format. I can send it, and it's gonna be received. And it's like here you can see we have console logs in the app. So we console log that the app received a message from the broker with this information. Now, the cool stuff is that this runtime validation of messages against the schema can be already plugged into the code generator. And in case of this Node.js app template, it's just plugged in. So you basically you don't have to do anything. You just have to provide schemas in your AsyncAPI document and see, like, I'm gonna send a broken information about lumens instead of integer. I'm gonna send a string. And that's it. Like we were able real time using the library that Walid provided to validate that the message is wrong, what's wrong about it, and to reject the message and not process it anymore. So that's what real-time message validation is. It's what this library is doing. It's basically reading AsyncAPI document. So when the message comes into the system, it can read from AsyncAPI document all the schemas that are available for a given channel and then just validate out of the box. But there are also other scenarios, like this is for Node.js. This here in this project that Sergio is working on, it's part of the gateway. So it's not even a library that is used by the app, but it's next to the app. Now, discoverability of traffic. So like imagine there are two types of companies: small startup, and huge corporation. Simplified world. In small startup, you have just few microservices probably at the beginning, not very complex, not many people, easy to share information. In huge corporation, you can have like, and I was there, I know there can be even 10 different teams working on the same product, and each can have multiple different microservices, and they communicate through event-driven architecture. How someone can know what messages are available in the whole system, what's going through the broker, what's happening, like what microservices we have. And that's what someone can do with AsyncAPI documents. So because if you treat this shit seriously, like you have an example, for example, of this social media, where to provide a social media product, you have to have multiple different services, UIs, backends, like service for comments only, and et cetera, et cetera. So you have multiple AsyncAPI files. So if you have multiple AsyncAPI files, you can define some rules like, okay, so if I have two AsyncAPI files and two of them have servers and both of them point to the same server, I can connect them. I can say, okay, they both are connected. So I can analyze these two documents and provide a kind of diagram, for example. And here you have the simplest example of diagram that is not the most beautiful, but that's just what you get out of the box. You can always style it properly. So we can see that, like, basing on few AsyncAPI documents, you can actually run it through some library, analyze, check what information you have in these documents, where they match, if it comes to the name of the channels, etc. So you can actually generate the whole architecture of your microservices. You know how and how they communicate, and you basically know that if you will unplug common service, that something can be broken across the whole architecture. So that's super helpful. And we know that users look into this use case a lot, especially Kafka users. Design first use case, that's something I already actually did throughout this whole onboarding. So creating AsyncAPI file for not existing application. I was designing the app, not having it yet. So that's what you can do normally without the spec. To design the app, to see the docs, I would just have to write it from scratch. And then again, you can imagine a group of 10 teams. Every team does it differently. Pretty hard to follow. Now, super powerful is prototyping and testing. So yeah, if you could see that I could super quickly generate some sample application that can already read messages, right? So you can imagine that I can write multiple AsyncAPI documents in the documents design that they communicate with each other through a broker on a given channel, and then I can actually generate all these apps and actually start them and actually do some stuff, like generate some messages, some fake messages. And that's what, for example, Microx is doing, that you just provide some examples, and basing on the examples, Microx will actually start generating these messages, like send them to the broker. So we can actually see how messages behave, how many messages you're getting in the system, etc. You can prototype everything, test everything without writing a single line of code, except of the code where if you're not using Microx, you might want on your own to write some loops that generate messages. That's it. So that's like kick-ass stuff, really. And like you can see on the scale of adoption of Microx, that it's super popular. Now, the code generation I could show you, but also it's not just about generating the whole application. You can generate also some client libraries from AsyncAPI files, but you can also let's say, using, let me close this one. You can generate using AsyncAPI CLI that under the hood uses our Modelino library. You can generate just models, for example, for JavaScript using the AsyncAPI file. Wait, I have to first. Yeah, into a proper location where I have AsyncAPI.yaml. So you can see that, like, yeah, travel data class, TypeScript class got generated like for you out of the box. So again, time saver, especially in typed languages. That's why, for example, I don't like typed languages, because there's a lot of boilerplate code. But if you can generate it, then it's super nice. And last, I can also tell you, like, that we know from the presentations of others, like Walmart, but it's also the same with Adeo. It's also the same with Bank of New Zealand. what they do is that internally, because they have a lot of communication done over event-driven architectures, they provide the whole self-service platforms where teams don't have to even talk to each other. Like Scrum Master from Team A doesn't have to go to Scrum Master of Team B and ask them like, hey, how can I connect to your models? Like, what to your API? What messages are you sending? Like, what channels? You don't lose time on it. You just go to a internal self-service platform where you can see all the applications from all the AsyncAPI files rendered into docs. You can like collect the information about all the messages, put them in one event catalog. So so basically, developer doesn't care basically about is it Shrek app or some different app sending the message, because for them it's irrelevant. For them, relevant is the message. So they want to first actually see that they can get a message about order placement, and they don't care what's the name of the application that is sending this message. They care about that the message exists, what's the payload, and then how to connect to the broker to actually be able to read the message. And that's what are different use cases, and it's just few, because like you can imagine, if it's machine readable format, then the sky is the limit if it comes to the use cases. Like a lot of talking. Code generation docs examples. I have few. So actually Shrek app is a real application. So I generated it. I can quickly show it to you. So I just have it cloned on my local, but it's on GitHub. The link is in the script. So just quickly looking on the code, like 80%, 90% of the code for this project was generated. So basically, using the AsyncAPI document for Shrek app, I was able to not only generate code, but of course, even publish the documentation, so we can see travel info, and the example, for example, is rendered to the one that I manually provided. So I can generate docs, I can generate app, and later I just have to provide some custom code. So in case of, let's just start the server. Yes, I just shared my token, but no worries. It doesn't work anyway. The app that I'm using is broken. But more important is that let's talk to the app. So you remember there were two channels. So WebSocket, you had to recall from part 2 onboarding, where I was using WebSocket to connect to the Kraken API. And here we're just connecting to WebSocket on localhost. Travel status. In this app, I'm not supporting query parameters, so we can't do destination BCN. That's not possible here. But yeah, let's connect. So we can see what's happening is that Sumi just wrote nice VS Code theme. Yes, thank you. Everyone tell me that. I love it. Like, I can't imagine working with different one. So yeah, you can see that I subscribed to a channel with travel status information. And now you can ask a question like, okay, but so you generated code using AsyncAPI. You had some sample data, but we do not recall that you were able to specify that distance is actually a number with kilometers. Like, you did not provide any sample data for names of the cities. So where is it actually coming from? So it's actually coming from the additional custom code that I had to add, because like I was just mocking the server. I did not intend to write a real life status app for the donkey. So basically, what code generation gave me chat.js, travel status.js, and all the code except of what is, sorry, let's make it a bit smaller. So I got all the code generated except what is inside the service. That's something custom. That's something you can't describe. That's like, so in the end, developers are still needed. They need to write this business code, but yeah, it's much more fun than just writing some validation code. So you can see here that I'm basically having a loop and using some library for generation of data. I'm just sending some data in a response to the channel. That's it really, and that's it. I really had to do. Like, I didn't have to all the colors, like that, the nice console logs, that this is in yellow, client connected. I didn't have to write this code. That was all generated. Okay, let's start the chat again. But yeah, chat will not work. There's something wrong with AI that I'm using. So I'm using actually real chatbot service, but something is broken with it. So I'm able to connect to the chat, send a message to Shrek bot, but now he always like the service returns empty answer. So my app says, like, if there's no answer, then it means your question is strange, and you're gonna be asked, like, is it you, donkey? Yes, it's me. But yeah, I provided intents for good morning and others, and it just stopped working. But yeah, I did it last year. But you get the feeling, like, of a chat, right? I'm sending message is received, and in the logs I can see that the information is coming. So that's it if it comes to the code generation. So you can install it on local, play with it as I just played. Docs tools, that's not so relevant. That's like one of many tools. But yeah, React component is the one that is actually also used in HTML template. It's just a different use case for the HTML template. And yeah, that's the main component that we use everywhere to render documentation. And that would be it. Oh, did I just finish it? I'm always losing the Zoom screen. Okay. So yeah, 1.5 hours. So we managed to actually complete the whole onboarding. So today you created, I hope you created, or I just created it, a real AsyncAPI document for a sample application. We used majority of features of AsyncAPI document with references, with bindings. So, but you definitely, if you didn't watch part 3, might be that part 4 is not that easy to understand. And we were able to see some in action code generation, message validation, mocking, some even design first approach. So do you have any questions? Because it's part 4, the last part. I will not do part 5 unless you give me feedback that something was not mentioned that requires more explanation, and I definitely can then provide something for you. But you just need to let me know. But so far, any questions anybody has at the end? Because we still have 30 minutes until the next live stream, so I can still stay here and answer some questions if you have them. Okay, I don't see also any questions in the live chat. So thank you all for joining, especially all the 4 parts of the onboarding. Not many people provided me feedback, so please, in DM, I'm really open. I'm actually most interested with negative feedback. So please share it with me, like tell me where I got lost, I lost you, because I think that this onboarding, it's for now on my private profile, but I used it already once on one conference, and I will apply to few next ones if they want to have some workshop that takes half a day. But I'd like to improve it. So if you have some feedback, like, well, where I lost you, where you think more explanation was needed, more details, then, or any other feedback, please really don't feel bad sharing it with me. I can handle it. I can handle negative feedback. So because I know it will just improve. Is there anyone still there on YouTube, or you decided to leave? Hey, YouTube folks, write something. And 10 seconds delay. Okay, everybody go. Everybody went, which is not strange, actually. 1.5 hours listening to me. Oh no, Summit, yes, awesome. So at least one person. Okay, thank you so much, folks. There's no need to keep it longer. Pedro, thank you for joining live as well.
Welcome, Lucas.
Yeah, and it was a pleasure to do it for you, folks. Thank you.